Very good evening, all of you. I am NP Raju, faculty at ACE Engineering Academy. I teach thermodynamics for GATE and other competitive examinations. I have been teaching thermodynamics since 13 years and I have been associated with ACE Academy since 2014. And today's session outline, let us see. We will be seeing syllabus analysis, detailed syllabus for thermodynamics. And what is the weightage for each topic and each and every chapter, we will be seeing what is the weightage analysis and what are the reference books required for this subject, thermodynamics, and how to prepare thermodynamics for GATE examination, preparation strategy. So this is the course outline for today's session. And what is thermodynamics? Thermo means heat. Thermo means heat. Dynamic means motion or power. Power is nothing but rate of doing work. So if you observe carefully, here heat and here it is work. So heat, work, conversion of this heat into work is known as thermodynamics. Suppose there is a heat. If this heat is supplied to the engine, so engine produces work. So this conversion of heat into work, this is known as thermodynamics. First, let us have a look on syllabus. And my dear friends, this subject syllabus is very vast. It is a huge syllabus. So we have to remember the syllabus is very vast. It is not possible to prepare each and every topic in this thermodynamic subject. So I will tell you, don't worry, I will tell you which area you have to focus more. Since I have experience, lot of experience, since 13 years I have been teaching, I will be telling you which area you have to focus more. I will be telling. And syllabus is very, very crucial for this subject. So if you see the syllabus mentioned in the GATE examination paper, if you see syllabus, they say thermodynamics and applications. In thermodynamics again, if you see, this is the syllabus directly I have taken from IIT Kharagpur website. This is the syllabus mentioned for thermodynamics. Directly I have taken the syllabus. And I will be going through each and every topic. I will be explaining. Do not worry, we will be seeing each and every point we will discuss with respect to the syllabus. So this is the syllabus given for thermodynamics in the website, right? And if you see applications, in applications they have mentioned like power engineering, IC engines, refrigeration, air conditioning, and turbo machinery. And again, power engineering and all these topics, they have mentioned some syllabus. Let us go through the syllabus. For power engineering, they have mentioned air standard cycles, that is air and gas compressors, vapor and gas power cycles, concepts of regeneration, reheat. Simply, they have mentioned this topic in the power engineering, but I will be explaining in detailed manner. What is the syllabus? In detailed manner, I will be explaining. In IC engines, they have mentioned air standard Otto cycle, diesel cycle, dual cycle. And for refrigeration and air conditioning, they have mentioned vapor and gas refrigeration, heat pump cycles, properties of moist air, psychometric chart, and basic psychometric processes. Again, here also I will be explaining each and every topic. In turbo machinery, they have mentioned steam turbines and also they have mentioned gas turbines. Anyway, gas turbines is already covered in the gas power cycles already it is covered, but anyway here also they have mentioned gas turbines already it was included in the previous part. And 2021, particularly in thermodynamics subject, in fluid mechanics subject you will be having turbo machinery, that is Pelton wheel, Francis, Kaplan turbines. But in 2021 GATE examination, they have included steam turbines also. Earlier it was not there. In GATE 2021, steam turbines also added. It was added in thermodynamic syllabus. And they have also mentioned gas turbines. But this gas turbine already covered in the syllabus. Previous syllabus it was there, but again they said gas turbines no problem. But here we have to remember that steam turbines is added, right? And first let us see, in thermodynamics, each and every topic, simply they say thermodynamic systems and processes. What does it mean? So thermodynamic systems. In thermodynamic systems, there is closed system, open system, isolated system. So these are types of thermodynamic systems. And processes, we will be saying constant volume process, constant pressure, isothermal process, adiabatic process, polytropic process. These are processes. Simply they mention systems and processes. So that is the meaning I am telling, that properties of your substances. So again I will be giving what is properties of pure substances, what are the various topics come under properties of pure substances, separately I will tell. So behavior of ideal gas and real gases. So what is ideal gas, and when a gas behaves as ideal gas, and what are the equations for ideal gas, and what are the examples of ideal gases. All these things will come under ideal gas and real gas. So in real gases also there are some equations and there are some concepts with respect to real gases also. Zeroth law of thermodynamics, first law of thermodynamics, calculation of work and heat and various processes, second law of thermodynamics. And remember, they simply said second law. In the second law, you will be having, simply they said second law of thermodynamics. But remember, here they have not mentioned entropy. Please remember, my dear friends, in second law, entropy also included, but entropy is not mentioned. Please be careful. Entropy also will come under second law only. Anyway, each chapter I will be giving what is the portion for detailed analysis. So second law simply they mentioned, but entropy will be there. Thermodynamic property charts and tables, availability and irreversibility and thermodynamic relations. This is the syllabus they have mentioned under thermodynamics in for GATE examination. Now I am going to take each topic name and I will be giving detailed analysis of the syllabus, because syllabus is very, very crucial. Simply they mention systems, processes, simply like that they mention, but there will be so many things we have to study, right? So in thermodynamics, if you see, actually there are basic concepts. Before we start thermodynamics, there are basic concepts. So basic concepts nothing but here, actually this is basic concept only. Thermodynamic systems and processes, they come under basic concepts only. So basic concepts means thermodynamics, systems, various types of systems, closed system, open system, isolated system, and various processes, constant volume, constant pressure, isothermal, adiabatic. So these processes will come, and also ideal gas concept will come. Ideal gas concept is extremely important because 80% of the syllabus, 80% of the syllabus, that is thermodynamics and also applications, 80% of the syllabus is based on ideal gas. So it is extremely important. Ideal gas analysis is extremely important. And remaining 20% of the total syllabus I am telling, 80% of the total syllabus comes under ideal gas, and remaining 20% of the syllabus comes under steam, that is properties of steam, that is wet steam, dry steam, superheated steam, and equations of wet steam, dry steam, superheated steam. So that also I will be telling, don't worry. So 80% is ideal gas only. So ideal gas concept comes under basic concept. And that is systems and processes and properties of pure substances. Here they said properties of pure substances. It is a separate chapter. Properties of pure substances is a separate chapter, and what are the topics come under properties of pure substances, I will tell you, don't worry. And zeroth law of thermodynamics. Already it is mentioned. Here, zeroth law, simply they mentioned zeroth law. Yes, it is a separate chapter. And first law of thermodynamics, it's a separate chapter. First law of thermodynamics and calculation of work and heat. It is a separate chapter. And second law, simply they mentioned second law. Just now I told, entropy also comes under second law only. And thermodynamic property charts and tables, availability, irreversibility, thermodynamic analysis. So thermodynamic relations. So if you observe this portion, so based on this portion, I am splitting into various chapters. This portion, whatever they have mentioned in the GATE syllabus, I am splitting into various chapters. Now let us see various chapters. That is basic concepts. In basic concepts, I said ideal gas analysis will come. What is ideal gas? What is perfect gas? What is semi-perfect gas? What are the various processes? And what are the various N values? N is polytropic index. N values for each process will be different. For isothermal, it will be 1. N value will be 1. Isobaric process, N is equal to 0. So each process there is N value. N values also we have to see in basic concepts. And we have to represent each process on PV diagram. That is extremely important concept. PV diagram concept is extremely important. Based on the slope, we will be representing N values. Based on the N values, we will be representing on the PV diagram. Each process, there is a slope. Slope of each process also comes under basic concepts. And what is property? And what are the various types of properties? Intensive properties, extensive properties, and some important points with respect to the properties. So that is properties are point functions. Change of properties independent of path, and properties are exact differential. These points are extremely important, and these points also they come under basic concepts. And types of systems and type of processes already I have told. So that is about basic concepts. Then properties of pure substances. Again, properties of pure substances. Again, I will split. What are the various topics I will split? So this is one separate chapter. Then zeroth law, it is a separate chapter. And first law of thermodynamics, it is a chapter, separate chapter. And work and heat, it is extremely important. Second law, entropy also, they have not mentioned, but entropy also comes under second law only. Available energy. So here, in available energy topic, it is a separate chapter. In this chapter, there are some other topics like what is availability, what is irreversibility. They also come under available energy chapter. It is a separate chapter. And then thermodynamic relations. So these are the various chapters which come under thermodynamics syllabus. Simply, this syllabus is called basic thermodynamics or thermodynamics, and it is extremely important. This portion of the syllabus, for if you take total syllabus, that is thermodynamics and applications, this syllabus is extremely important. Thermodynamic syllabus is extremely important because it has lot of significance. Because unless you prepare thermodynamics, you can't go applications. You can't go and prepare applications. In applications, you have 8 standard cycles, gas turbines, steam turbines, refrigeration, psychometry. So these chapters, if you want to prepare, basic thermodynamics is must. That's why this chapter, thermodynamics, is extremely important. And in basic concepts, let's have some light on basic concepts. See, basic concepts is the building block. See, for entire syllabus, thermodynamics is extremely important. And for thermodynamics, basic concepts is utmost priority. Because unless you prepare basic concepts, you can't study thermodynamics. So that's why basic concepts are like building blocks. So in basic concepts, we'll be seeing what is gas, what is ideal gas, what is vapor, what is the difference between gas and vapor, under what situations it behaves as gas, under what situations it behaves as vapor, and what is ideal gas, what are the various examples of ideal gases. So all these things, they come under ideal gas concept. So ideal gas concept is extremely important. And the various processes, already I told constant volume, constant pressure, isothermal, adiabatic, polytropic, these are various processes. Throughout the syllabus, these processes will repeat. So that's why these processes are extremely important, because every time they will be repeating in the syllabus. Even if you go to applications part, same processes will come. So that's why this is extremely important. So this is the PV diagram for all the processes. Constant volume, constant pressure, isothermal, adiabatic, polytropic. For all the processes, this is the PV diagram. So N values are extremely important. If N value is 0, constant pressure, N is 1, isothermal, N is equal to N, polytropic, N is gamma, adiabatic, and n is equal to infinity, constant volume. So each process there is a value of n, that is polytropic index, and if the n value is changing, the process also will change, and slope also will change. So this constant pressure, isothermal, polytropic, adiabatic, and constant. So slope also will change. Slope concept is extremely important. N values are very, very important. So these are all very extremely important concepts, so which will be there in the basic concepts. So what is system? These are all the important terms in thermodynamics. What is system? What is surroundings? What is boundary? What is universe? These are all extremely important, because throughout the syllabus, these are the terminologies we will be using. And surroundings, generally you say outside the system or external to the system surroundings, but that is not the correct definition. Definition of the surroundings will be something different. So that will be different, again concept, this is a different concept, because outside the system, if you say surroundings, it is not correct. So outside of the system, there may be effect, there may not be effect. If effect is not felt outside of the system, that cannot be a surroundings. So anyway, that is a different thing. So these are important terms, and these are some definitions, important definition. What is state, what is process, what is path, what is process, quasi-static process, reversible process, irreversible process, and what is thermodynamic cycle and thermodynamic equilibrium. These things also very, very important throughout the syllabus. And zeroth law of thermodynamics. Generally, the weightage is very, very negligible for zeroth law, but anyway, weightage analysis I will do separately. So we will be seeing what is the statement of zeroth law, and temperature measurement is based on zeroth law of thermodynamics. What is adiabatic wall? What is diathermal wall? What is thermometric property? What is thermometric substance? And what are the various types of thermometers? So everything will come under zeroth law of thermodynamics. Simply they say zeroth law, but so many things will be there. So resistance thermometer, thermocouple, constant volume gas thermometer, constant pressure gas thermometer. So temperature scales, and what is the relation between various temperature scales? Suppose there is a degree centigrade scale, there is a Fahrenheit scale. What is the relation between degree centigrade scale and Fahrenheit scale? So that is also important. So how to convert degree centigrade into Kelvin? So generally you add 273, but why we are adding 273? That is extremely important. So what is absolute zero? What is absolute temperature? Absolute zero is different, absolute temperature is different. And absolute temperature has other name, that is Kelvin scale. Why absolute temperature is also called Kelvin scale? And these are all the things, very, very important things in thermodynamics. Next, heat and work. Simply they say heat and work. But what is work from mechanics point of view? But mechanics point of view, work transfer is different. In thermodynamics point of view, work transfer is different. Both are almost same, but in thermodynamics point of view, work transfer is something different. Just like mechanics point of view, you can't take force into distance. You will be in trouble, my dear friends. So there is a difference. What is the difference? That will be different concept. So what is work, and what is mechanical work transfer? What is electrical work transfer? What is moving boundary work transfer? So many things will be there. So types of work transfers will be there. And work transfer, if you represent on PV diagram, it's a path. So work transfer is a path function. Why it is a path function? Why it is not a property? So what is property? What is path function? Difference between property and path function. So many things we need to see. Types of work transfer, moving boundary work transfer, spring work transfer, and paddle wheel work transfer, electrical work transfer. So these are all various types of work transfers. And that it is this concept is extremely important. What is the difference between heat and work? Thermodynamics point of view. In thermodynamics point of view, what is heat, what is work? So it is an extremely important concept, because if you see both the systems almost same. Here there is a container, and here also there is a container, but here we will be seeing it is work transfer, and here there will be heat transfer. What is the difference? That is extremely important. That varies actually. Heat and work, both there is a difference. Both seem to be, containers are same, but there is some difference, right? So what is heat transfer? So actually heat transfer means it should cross the boundary. So heat transfer is different, heat generation is different, heat exchange is different. So everywhere there is a difference. If you miss the difference, gone. If you miss the difference, gone. So that is a, see, if suppose there is a boundary here, within the boundary, suppose if this is hot body, this is cold body, both are in contact. So this is losing heat, this is gaining heat. So just they are exchanging heat, but it is not heat transfer. But what is heat transfer, what is heat generation, and what is heat exchange? Each one is different. So what is heat transfer? What is equation of heat transfer? Equation of heat transfer. Equation of heat transfer. We will be seeing Q is equal to MC delta T. So this is equation of heat transfer. And what is specific heat? From this equation, we will be deriving specific heat. So specific heat at constant volume denoted by CV, specific heat at constant pressure denoted by Cp, and ratio of Cp by Cv, that is known as gamma, adiabatic index, or ratio of specific heats. So what is Cv, what is Cp, what is adiabatic index, and what are the specific heats of gases? For gases, what are the specific heats? Because for gases, specific heats are different, and for solids, liquids, specific heats are different. And what are the specific heats of solids and liquids? Solids and liquids. Both are different. Both are different. Gases, specific heats are different. Solids, liquids, specific heats are different. The change, specific heats change. So that is very, very important. The difference is very, very important. And first law of thermodynamics. So before first law, we need to study what is heat, what is work. And work is energy. Work is form of energy. Heat is also form of energy. Both are energies only. That's why they called energy interactions. Heat and work, they are called energy interactions. So I told just now, thermodynamics means, thermo means heat, dynamic means motion or power is nothing but rate of doing work. So work, that is heat into work, conversion of heat into work, thermodynamics. So work and heat, work and heat. So these are work interactions. Throughout the syllabus, whatever may be the chapter, anywhere, whether it is thermodynamics or applications, we are interested in work interaction and heat interaction. So after studying work and heat, so based on work and heat, we will be saying first law of thermodynamics. So in first law of thermodynamics, various forms of energies. What is energy? What is energy in transit? What is energy in storage? So actually heat and work, they come under transit form of energy. What is the meaning of transit? What is the meaning of transient? They ask. With respect to heat and work, they will give some points. Heat and work, boundary phenomena, transient, transit. So many things. Exact differential, inexact differential, path function, point function. So many things they will give. Generally, usually 1 mark questions will come. Similarities between heat and work, generally 1 mark question, generally it will appear. So these are transit form of energies. And some are storage form of energies. In storage, again, macroscopic is there, microscopic is there. So again, macroscopic, there are kinetic potential, and microscopic internal energy is there. So these are all storage form of energies. So energies only, but there are some differences. There are differences, very, very important. So internal energy, it is extremely important. Internal energy. So the energy is stored in the system. The energy stored in the gas molecules in the system. That is, various forms are translational kinetic energies, rotational kinetic energies, and vibrational kinetic energy. All these forms of energies put together, that is known as internal energy. So that is a concept. Internal energy concept, it will be there in the first law of thermodynamics. Internal energy. And what is free expansion? So what is enthalpy? What is internal energy? What is enthalpy? And what is Joule's law? Joule's law states that for an ideal gas, internal energy is function of temperature only. For an ideal gas, internal energy is denoted by generally U, function of temperature only. It is an extremely important. For an ideal gas, internal energy is function of temperature, and enthalpy also will be saying enthalpy is there. Enthalpy also, for ideal gas, enthalpy also function of temperature. Enthalpy also function of temperature. And ideal gas relations, extremely important. And in first law, closed system analysis is there and open system analysis is there. So in first law, there is some part of analysis with respect to closed system. And closed system energy equation is different. Open system energy equation is different. And again, open system steady flow is there and unsteady flow is there. And steady flow energy equation is different. Unsteady flow energy equation is different. So in first law, if you see total first law, if you see there is a closed system and there is open system. Again, in open system, steady flow is there, unsteady flow is there. So there is a, simply they say first law of thermodynamics. Unsteady flow nowadays, they are asking frequently. But earlier, there was no weightage for unsteady flow. Only earlier in 2008, IIC Bangalore, there was a question. Up to 2008, there was no question. They have never asked unsteady flow. In 2008, first time they have introduced one question from unsteady flow in gate examination. But after that, they have never taken that question in gate examination. But again, trend started unsteady flow. Unsteady flow, we have to prepare. Now the trend has been changed. Again, they are focusing on unsteady flow. Unsteady flow is important. So closed system equation is different, open system equation is different, and ideal gas relations. There are some ideal gas relations. For ideal gas, PV is equal to RT. PV is equal to MRT. P is equal to rho RT. PV is equal to N R bar T. And for ideal gas, du is mCV dt. dH is mCp dt. And CV is R by gamma minus 1. And Cp gamma into R by gamma minus 1. And Cp by Cv is gamma. So these relations, whatever just now have written, these are extremely important. Extremely important. I said 80% of the syllabus is based on ideal gas. And throughout that 80% of the syllabus, we will be writing these equations only. Whether it is thermodynamics or applications of thermodynamics, these relations are extremely important. That's why ideal gas analysis is very, very important. So in first law, open system. So what is steady flow? It is open system. And for open system, steady flow energy equation. What is steady flow? What is continuity equation? What is flow work? It has some significance. Flow work has some significance. Flow work. And steady flow energy equation. Some applications of steady flow. So in applications of steady flow, that is open system. There is a turbine, there is a compressor, there is a nozzle, and there is a throttle valve. It is also application of steady flow energy equation. So these are all examples of steady flow, which comes under open system. And also unsteady flow is there. In first law, unsteady also there. So in open system, steady flow energy equation is there. That is energy balance equation. There is mass balance equation. There is energy balance equation for steady flow. Similarly, for unsteady flow also, there is mass balance equation and energy balance equation. So unsteady flow also extremely important. And second law of thermodynamics. And in second law, there are some statements. Clausius statement, Kelvin-Planck statement, Clausius statement related to some devices. Kelvin-Planck statement is related to some devices. Both are different. Two statements we have. Kelvin-Planck statement is related to heat engines. Heat engines. What is heat engine? What are the examples of heat engines? Heat engine is something which produces work by using heat. What are the examples? IC engine, steam power plant, gas turbine power plant, rockets, jet engines, all these comes under, they come under IC, that is heat engines. So Kelvin Planck statement related to heat engines. Clausius statement related to refrigerators, heat pump. So these both are different. Heat engines, they produce work. Refrigerators and heat pumps, they are absorbing work absorbing devices. They are heat engines work producing devices. So there is a difference. And what is heat source? What is heat sink? What are the examples of heat sources? What are the examples of heat sink? So these things will come under second law of thermodynamics. Let's take a small break, then we'll move on. So let's start and continue. the session. So what is heat source? What are the examples of heat sources? And what is heat sink? There are some various examples of heat sink and heat engine. And these concepts are very, very important, and frequently questions come from second law. And one of the student I think asked, is there any syllabus change? Right now, whatever the syllabus I am explaining, right now this is the syllabus. Suppose if there is any change in the syllabus, it will be updated in the website. As of now, this is the syllabus. Whatever the syllabus I have given at the beginning, so that is the syllabus right now. If is there any suppose change, it will be updated, right? So heat engine, refrigerator, heat pump, these concepts are extremely important. And what is difference between refrigerator and heat pump? And what is difference between heat engine and heat pump? And there is a relation. Heat engine, heat pump, there is a relation. What is the relation between heat engine and heat pump? And what is relation between refrigerator, heat pump? Important. And combined heat engine, refrigerator. Combined heat engine, heat pump. These concepts also very, very important. And what is Clausius inequality? Important. Clausius inequality. Cyclic integral of q by t less than or equal to 0. This is known as Clausius inequality, which is extremely important. And based on this Clausius inequality, entropy is derived. So this is extremely important, Clausius inequality. And what is Clausius inequality for reversible cycles? What is Clausius inequality for irreversible cycles? So what is Clausius inequality? So these things also very, very important. And based on Clausius inequality, entropy is derived. What is entropy mathematically and what is entropy physically? Disorderness. Entropy physically meaning disorderness, randomness, or chaos, or disturbance. So physically also there is meaning. So what is entropy of gases, liquids, solids? You will be seeing with these equations for change of entropy of the ideal gases and solids, liquids. And whatever the processes we have means there are processes in the basic concept. For the same processes, here TS, temperature entropy diagram will come. Simply they say second law, but second law, heat engine, refrigerator, heat pump concepts and also entropy concepts. In entropy also, there are so many concepts involved. What is temperature entropy diagram? What is heat transfer? The area on the TS diagram represents heat transfer. And again here, each process slope is different. So whatever the processes we represent generally on PV diagram, same processes we can represent on TS diagram. So here this is complete the TS diagram for various processes. So this is the TS diagram. And in entropy, so change of entropy for ideal gases, change of entropy solids, liquids, change of entropy for thermal reservoirs, and change of entropy due to mixing of gases, due to mixing of liquids, and finite bodies, change of entropy for finite bodies. What is finite body and what is the change of entropy for finite body? So when heat engine operates between finite body and refrigerator and heat pump, when they operate between finite body, there are change of entropy equations. So this is entropy. And available energy. Again here for a cycle, the maximum work which is known as available energy. For a process, it is availability for cycles and processes. And what is irreversibility? And that is available energy concept and thermodynamic relations. And generally the weightage, available energy, the weightage is very, very small. Frequently the questions don't come for GATE examination. The weightage is very, very less. Thermodynamic relations. This part also, thermodynamic relations, it was added in 2016. In 2016 it was added, but I think 2016 there was a 1 mark question. But then they have not asked the thermodynamic relations. Till now they have never asked. Only 2016 they have asked 1 mark question. And what is Gibbs function, Helmholtz function, and CP-CV relation? So generally we write the CP-CV is R, but there are some other relations also, thermodynamic relations, and pure substances. It is extremely important chapter. properties of pure substance is the extremely important chapter. Because why it is important? I told 80% of the syllabus is ideal gas, based on ideal gas equations. And remaining 20% of the syllabus, that is Rankine cycle, steam turbine, refrigeration, psychometry, or all these topics, just based on properties of pure substance. Without this chapter, you cannot go through, you can't analyze Rankine cycle, psychometry, steam turbines, and refrigeration. So that's why this chapter is extremely important for remaining 20% of the syllabus. And what is pure substance? What are the various examples of pure substances? What is TS diagram? What is HS diagram? What is PV diagram? What is a PT, pressure temperature? That is different. So HS diagram. So various diagrams are extremely important. And what is the condition for evaluation of steam, whether it is dry steam, wet steam, superheated steam, or subcooled liquid, or saturated liquid. So there are, that is with respect to specific volume, enthalpy, internal energy, there are conditions. How to check whether the steam is wet, dry, or superheated. So there are so many conditions here. And steam table, they have mentioned in the syllabus, property charts and property tables and charts. Steam table is a property table. And psychrometric chart will come, property chart and property tables. And just now we have seen the syllabus. This is thermodynamic syllabus. This is the thermodynamic syllabus. And applications. In applications, power engineering, IC engines, just now I told, refrigeration, air conditioning, and turbo machinery. Each one we will discuss. In power engineering, they have mentioned this is the syllabus. They said air and gas compressors. That is nothing but compressors, simply air compressors or gas compressors. But remember, it is not rotodynamic compressors are different. Rotary compressors are different. It is not rotary compressor. Simply, it is air compressor. That is nothing but reciprocating compressor only. So, reciprocating air compressor. So, air compressors. And based on this syllabus, so again, I am splitting into various chapters. So, air compressors is a separate chapter. Vapor and gas power cycles, they said. Vapor cycle, they mentioned. That is nothing but Rankine cycle. You need to understand it is a Rankine cycle. They said gas power cycle. It is a gas turbine cycle. That is Breton cycle. So simply they said vapor power cycle, that is Rankine cycle. Gas power cycle means it is a Breton cycle or gas turbine cycle. Concepts of regeneration and reheat. In Rankine cycle, there is regeneration, reheating. And gas turbine cycles also, there is a regeneration, there is reheating. And again, in gas turbines, intercooling also is there. Intercooling, reheating, and regeneration. In steam power plant, superheated Rankine cycle, reheat Rankine cycle, regenerative Rankine cycle. These three cycles are extremely important. Rankine cycle is extremely. And I will tell where to focus. Applications part, you focus. Because roughly, I will be telling in the weightage analysis, generally thermodynamics, the weightage, roughly 5 to 6 marks. Application, also roughly 5 to 6 marks. Roughly 12 to 15 marks, thermodynamics weightage. My advice is focus on applications. Applications are very, very easy. And definitely, there are some questions. I will tell, don't worry. So, concepts of reheat reagent. This is power engineering. So based on power engineering, you have air compressors. That is reciprocating air compressors only. There is no rotary compressor. Rankine cycle, gas turbines. So out of these three, and air compressors, there is no weightage. Weightage is negligible because it was added. Air compressors, they have added in 2016. In 2016, there was one question, but 2017, 18, 19, 20, 21, no questions. They have not asked any questions. No questions are asked from the air compressor. So weightage is very, very negligible, but Rankine cycle, extremely important. Gas turbines. At the ending, I will be telling which chapters you have to focus more. Air compressor. And again, air compressors, what is single acting compressor? Single acting compressor. So what is single acting compressor? Single acting compressor and double acting compressor. What is single stage compressor? Multi-stage compression. What is clearance ratio? And what is the work input equation? with clearance equation is different, without clearance equation is different. There are two cases. And what is volumetric efficiency? Extremely important. Volumetric efficiency equation is very, very important, which will come under this equation. Same equation will be coming in the refrigeration also, vapor compression cycle also. They will be frequent. Sometimes they ask volumetric efficiency. Same equation also will come, because in vapor compression cycle, in refrigeration, there is a chapter, that is a topic called vapor compression cycle. In vapor compression cycle, there are four components: compressor, condenser, expansion valve, and evaporator. The compressor is generally reciprocating compressor only. So same equation will come. So what is intercooling? What is two-stage compressor? That is multi-stage compression. What is the significance of multi-stage compression? Why we should go for multi-stage compression rather than single-stage compression? So what is polytropic efficiency? What is isothermal efficiency for compressor? And what is free air delivery? FAD, generally we say, that is the capacity of the compressor. If you want to purchase the compressor, we have to check free air delivery, that is FAD. So this is reciprocating air compressor. IC engine. This is the syllabus they mention: air standard Otto cycle, air standard diesel cycle, and dual cycle. Air standard, that is Otto and diesel, extremely important. Otto cycle, air standard Otto and diesel cycles are extremely important. Generally, not generally, till now they have never asked a dual cycle. Till now, last 36, 37 years, they have never asked dual cycle. So Otto and diesel, extremely important. And this is the syllabus, but generally Otto diesel only questions, no dual cycle questions. So that is air standard cycle. Separately, so if you go through the textbook, there is a chapter that is air standard cycle. So just it is a air standard cycle. So everything comes under air standard cycle only. So in refrigeration, air conditioning, so this is the syllabus they have mentioned. Vapor and gas refrigeration. Vapor refrigeration is nothing but vapor compression refrigeration cycle. Gas refrigeration is also called air refrigeration. Both are different. Both are different. Air refrigeration is used in aircrafts, and vapor compression is used in domestic refrigerators, air conditioning systems. Most of the applications are vapor compression only. Definitely, vapor compression question will be there every year, at least once in 2 years. Vapor compression, extremely important. And gas refrigeration, they have never asked any question. Till now, they have never asked gas refrigeration. That is air refrigeration, they have never asked. So you can leave air refrigeration. Generally, I am telling. So heat pump cycles. So in second law, you will see what is heat engine, what is refrigerator, and heat pump. So here, heat pumps also operate on refrigeration cycle only. But difference is heating effect. Refrigeration cycle, cooling effect; heat pump, heating effect. So there is a difference. And properties of moist air. What is humidity? What is specific humidity? What is dry air? What is moist air? And what is relative humidity? What is specific humidity? What is dry bulb temperature? What is wet bulb temperature? So these concepts come under properties of moist air. Dew point temperature also. Enthalpy of moist air. And psychometric chart. There is a chart called psychometric chart. And based on the psychometric chart, there are psychometric processes: sensible cooling, sensible heating, humidification, dehumidification, cooling, dehumidification, heating, humidification. Cooling, dehumidification is used in summer. In winter, heating, humidification is used. And adiabatic saturation and chemical dehumidification. So these are all processes, psychometric processes. So this is the syllabus they have mentioned. So this syllabus, if you split into chapters, vapor compression cycle, air refrigeration cycle or gas refrigeration cycle, and psychometry. So these three chapters will come under refrigeration and air conditioning. Vapor compression, extremely important. Air refrigeration, no questions. They have never asked any question. And psychometry is extremely important. Frequently questions come from vapor compression and also psychometry. So vapor compression. In vapor compression cycle, so we will be the COP. What is COP? Vapor compression cycle. What is the work input to the compressor? What is the cooling effect? What is heating effect? What is COP of refrigerator? And what is the COP of heat pump? Vapor compression heat pump. So what is the volumetric efficiency of the compressor? In the refrigeration cycle, there is a compressor That is generally reciprocating compressor. So what is the volumetric efficiency of reciprocating compressor? Sometimes they ask. Generally they ask COP or generally work input or cooling capacity, ton of refrigeration, important. They ask sometimes ton of refrigeration, that is nothing but cooling capacity. Generally we say 1 ton AC, 2 ton AC. Strictly speaking, that is wrong. You should not say 1 ton AC, 2 ton AC. TONNE is different. TONNE means mass. You should say ton of refrigeration. 1 ton AC means it is 1 ton of refrigeration. So that is ton of refrigeration. That is vapor compression. Air refrigeration cycle, again here ideal gas, just it is an application of ideal gas. And psychometry, just now I said, what is dry bulb temperature? Dry bulb temperature, wet bulb temperature, dew point temperature. So these things are extremely important. Each temperature there is a pressure. So dry bulb temperature, wet bulb temperature, dew point temperature, generally they are different. Pressures also corresponding to these temperatures, pressures also different. But under saturated conditions, all these three temperatures will be same, pressures also will be same. So that is an important concept. So turbo machinery. In turbo machinery, they have given, this is syllabus, steam turbine and gas turbine. Already gas turbine is covered. Gas power cycles is nothing but gas turbine. Steam turbines, they have introduced in 2021 gate examination. 2021, no question. 22, no question. There was no question on steam turbine. So generally the weightage is very less. Weightage is less. Steam turbines, weightage is less. So in steam turbine, what is impulse turbine? What is reaction turbine? What is degree of reaction? What is impulse effect? What is reaction effect? And what is the blade efficiency or diagram efficiency? What is the velocity triangle for impulse turbine? What is velocity triangle for reaction turbine? So simply they said impulse turbine, but there are compounding, pressure compounding, velocity compounding, everything come under steam turbine. So that is steam turbines. In turbo machinery, particularly in thermodynamics, you need to go through steam turbines. So I am not writing because it is 1 hour session, it is almost 1 hour. So that's why I am not representing, just orally I am speaking. So steam turbines. So weightage generally 12 for gate examination, 12 to 15 marks. Average, on and average you get 12 marks. Maximum it will be up to 15 marks. This is the weightage for thermodynamics and also applications. And complete syllabus analysis I have given. The same manner, I want to discuss weightage analysis. Generally, the weightage is 12 to 15, but in detailed manner, suppose I want to give weightage analysis. So let us see. Basic concepts, generally 1 mark question, 1 or 2 mark questions. They come, 1 or 2 mark questions come from basic concepts. 1 mark questions or 2 mark questions. Extremely important. Basic concepts extremely important. 0th law, no questions, 0 questions. 0th law, 0 questions. Because it is a very fundamental basic law, generally no question. They have never asked any questions. No questions were asked from 0th law till now. So you can leave this one. That's why I said the syllabus is very vast in thermodynamics. So you can leave, because whatever I say means weightage analysis I am giving. 80% of the syllabus it will match. The questions, if you see previous gate questions or coming year gate questions, 80% I can give guarantee. 80% of the syllabus, weightage whatever I am going to give, it will match with your gate examination paper. 80% I can give guarantee. Remaining 20% I cannot give. So mostly because I have been observing the papers, how the questions are appearing, how the questions are framed, and what type of questions are framed, from which topics the questions are coming. So I know very well, that's why 0th law you can leave. Work and heat extremely important. 1 mark question or 2 mark questions. It is extremely important. First law also extremely important. So there may be 1 mark question or there may be 2 mark question. Second law, extremely important. So there may be 1 mark or 2 mark question. Entropy is extremely important. There may be 1 mark question or 2 mark question. Entropy also very, very important. Frequently questions asked from entropy. Available energy, the weightage is very small. The weightage is very, very small. So generally there are no questions. Based on the past examination papers analysis, I am telling. Because 100% syllabus, it is not possible to prepare. 80% I can give guarantee. So generally there are no questions. Available energy. Thermodynamic relations, I said 2016 it was added, only there was one question till now. You can leave it. Pure substance, extremely important. 1 mark or 2 mark questions. And anyway, you need to prepare. Based on this, I said, based on this chapter only, you can analyze Rankine cycle, refrigeration, psychometry, and steam turbine. You must go through properties of, there is no exemption. You have to prepare. So this is about basic thermodynamics. And in applications, air compressor, it was added in 2016, just one question asked. Up to till now, they have asked one question. One question was asked from this topic. Rankine cycle, extremely important. 1 mark questions may come, 2 mark also may come. 8 standard cycles, very, very important. 1 or 2 mark questions may come. Means 1 or 2 mark questions means minimum 1 mark, maximum 2 mark. Wherever I am writing 1 mark or 2 mark means minimum 1 mark question, maximum 2 mark questions may come. Vapor compression, extremely important. Vapor compression cycle is extremely important. Air refrigeration, they have never asked any question. No questions were asked from this topic till now. Psychometry is extremely important. So minimum 1 mark, maximum 2 marks. Steam turbines, they have added in 2021. 21, there was no question. 22, there was no question. So that is the reason I say the weightage is very small. But I said 80% only. I said 80% it matches. Whatever I am saying, maximum 80%. Right. So this is the weightage analysis, detailed weightage analysis I have given. So based on the weightage, you can prepare. So that is the reason I have given reference books. So now the important question is that what are the various books, reference books required for thermodynamics? It is P.K. Nag textbook. Numericals, you will get lot of variety numerical problems. If you want lot of numericals, different varieties of problems, it is the best book for numericals. And this is the excellent book for thermodynamics. You love this book. If you start reading this book, you enjoy reading thermodynamics. It's a Bowles and Sengel. I think it is not visible. It is Bowles and Sengel. So beautifully concepts are given, beautiful diagram, beautiful explanation, everything, you enjoy it. So this is the book. And questions also good, numericals also good, but numericals are less compared to P.K. Nag. So that is the reason I said theory, excellent. And this is Moran and Shapiro. So generally P.K. Nag, Bowles and Sengel more than sufficient. But still if you want, you can go for Moran and Shapiro. And this is Borgnag and Sontag. I think it is visible. Borgnag and Sontag. Sometimes Van Wylen also will be there in the textbook. Author name Van Wylen also will be there. Or Borgnag and Sontag will be there. So this is also a beautiful textbook. So some additional textbooks I am giving. So these are the reference books. And how to prepare? It is a $1 billion question. Preparation strategy. So logical sequence, because it is a very huge syllabus, it is a vast syllabus, so we should know how to prepare logically, because so many chapters are interconnected, interlinked. If you prepare one concept, the same concept will repeat. So that you should remember how to prepare logically, that is important. For example, I said 80% of the syllabus ideal gas. 80% ideal gas. These are all the chapters which come under ideal gas analysis. If you know ideal gas equations, you can happily complete this syllabus. This portion you can happily, without going through the steam properties, that is wet steam, dry steam, superheated steam, without going through the properties of pure substances, happily you can go through this syllabus. You can finish off. So that is the beauty. Everywhere ideal gas relations only. Even applications also have taken air compressors, gas turbine, air standard cycles, air refrigeration cycle. Applications also, these are all basic thermodynamics applications also. Beautifully you can complete just going through the ideal gas concept. So that is the logical sequence, logically. So if you have ideal gas relations, you can complete beautifully, right? And property, pure substances, I said already, it is extremely important. Properties of pure substances, extremely important. Without this chapter, it is very difficult to analyze these 4 chapters: Rankine cycle, steam turbines, vapor compression cycle, and psychometry. So before you start these 4 chapters, you must go through properties of pure substances. And once, if you are free with, means once you are completing the properties of pure substances, if you are already complete, there is no problem. Absolutely there is no problem. First complete this one, then go for remaining. Beautifully it will be over. Everywhere, same concept only. Remaining 20%, 80% ideal gas, and 20% of the syllabus steam, just steam properties. Whatever you study here, just application, that's all. So that is a interconnection. So that is a connection between these 5 chapters. 20% of the syllabus. You will be completing very easily if you complete this one. So that is the logical sequence. Selective logical sequence means only I am telling about ideal with respect to ideal gas and steam only. I said logical means which chapter first one, which chapter second, I did not say. But if you know ideal gas, happily you can complete this one. If you know steam properties, you can happily complete this one. Logically means first you go for vapor compression or steam turbine. I cannot tell like that, but you can complete. If you know this chapter, directly you can jump. That is the sequence I said. Logical sequence. Selective preparation is very, very important. I said 100% preparation, it is not possible because time is very limited. You have huge syllabus. 100% syllabus is not possible. 80% of the syllabus you take. Selective preparation means 80% of the syllabus you take. But whatever the syllabus you take, 80%, you should go through each and every corner. You should not leave single topic. Thoroughly you have to study. 80% thoroughly means thoroughly you have to prepare. So selective preparation you have to do. Conceptual preparation, because it is gate examination. Conceptual questions. Only they ask conceptual questions. Superficially, if you prepare, it is not possible for gate examination. Conceptual questions. Each concept you have to study. Conceptually, you have to study each and every topic. Concepts are extremely important. You have to study conceptually. Superficially, it's not possible. Conceptual preparation, chapter-wise synopsis. Once you have done with one chapter, one chapter suppose you have completed, you have to write synopsis. Bullet points you have to write. And you have to write important formulae. So that is called synopsis. For each chapter, you write bullet points, important points, and also formulae. And that will be helping you to revise the subject. For revision, quick revision, it will be useful. And focus on numericals. My dear friends, GATE exam is purely numerical based examination. Don't expect any theoretical questions. Generally, sometimes theoretical questions also come, just 1 mark question, theoretical questions may come, but we don't know when they ask theoretical questions, we don't know when they appear. But numericals only, GATE means numericals only. Don't prepare theoretical questions. You have to practice maximum number of numericals. As maximum as possible, you have to prepare numericals only. You complete one concept, you try to solve maximum number of numericals only. And it is extremely important. Previous GATE examination, extremely important. Minimum 20 years of previous GATE. At least 20 years of previous GATE examination papers you have to solve. Not only for thermodynamics, for any subject. Minimum 20 years. Then only you will get an idea how the questions are framed, how the concepts are coming, and how to tackle these questions. Then only you will get an idea, so that it will help a lot in your examination. If you prepare previous GATE examination, according to me, absolutely there is no doubt. You will attempt maximum number of questions. If you prepare previous GATE year questions, definitely you will be in a position to solve maximum 80% of the questions you will be solving. Sometimes same questions only, repeated questions only will come. Sometimes, not always. Just they change numericals. Sometimes repeated questions also will come. But anyway, you have to prepare previous GATE examination papers. Test series also important. So test series, time management. So you should go through test series. So practice. Test series you have to practice. Then only you will know time management. So how much time you are taking. So whether you are taking less time or more time, you will come to know. Time management is also extremely, because within 3 hours you need to complete examination. So time management is also very crucial. So you have to give test series. Then only you will come to know your how much time you are taking. So that you will come to know when you give test series. If you don't give test series, it is very difficult, right? This is also important. Now, suppose in test series, suppose your performance is less, your performance is low, don't worry, don't get demotivated. It is just for practicing only, So again, what to do? You have to revise and improve. After giving test series, you have to revise and improve. So that is the preparation strategy. So you have to think in such a manner, so how the chapters are interconnected, how the various concepts are interconnected. So that is number one. And you have to take some 80% of the portion. Thoroughly you have to prepare with each concept detailed manner, conceptually detailed manner you have to prepare. Then you have to write synopsis, and that will be helpful for revision. And I said 80%. Why 80%? Because your aim is to crack the examination, not to do any PhD. You are not going to do any PhD. Your aim is to just crack the examination. Just you want to get into some IIT or IISc, or you want to get a job. So that's why 80% you take, thoroughly you prepare. Numericals only. You have to thoroughly prepare numericals. Previous year extremely important. Test series for practice, and time management is also important. And you have to revise, and you improve. You have to revise. One subject is over. Suppose you are going for next subject. You have to revise completed subject. At least once in a week you have to revise. Synopsis. Don't go through the complete subject. It takes a lot of time. Only synopsis you prepare. Means already one subject completed, second subject started, preparation. You started second subject, preparation. First subject, whatever synopsis you have already prepared, you go through the synopsis at least once in a week, so that you will remember the previous subject also. Otherwise, you will forget the previous subject. Whatever you are studying, that you will be concentrating more, but whatever the completed subject, you will forget everything. So that is the reason. So these are the various steps for the preparation, your preparation. So this is the preparation strategy. So all the very best, and thank you everyone.